Well, hi, good morning, and thanks so much for joining me here in my shop on January 21st. And boy, oh boy, is it cold here. Now, the last video I did was a look at that power supply, which is still sitting there on my bench. That was a while ago, 5, 6, 7 days ago, I'm not even sure. I've been a little under the weather and haven't done anything for that length of time. But in the meantime, this arrived. Yes, from Stephen's Butcher Shop. No, it has nothing to do with Stephen's Butcher Shop. Port Carling, Muskoka. There you go, Stephen's. Never been there. Let's look inside here. It has something to do with that power supply. And what is that scratching sound? That's the cat in a litter box in the next room, unfortunately. I may have to clear out of here pretty quick. Let's see what we got here. What do we got? We got more than I expected. Oh my gosh. Let's take a look here. So this is everything that goes with this power supply, which I determined was defective, but look, it's still here. They haven't tossed it out yet. Here's the radio that goes with it. Black and Decker Firestorm. Looks like parts trays. Yeah. Cool. AM, FM, volume control. Great big thing here. So I've never seen one of these before. I really haven't studied up on this all that much, really. Not really at all. And the owner of the power supply, who hoped I could fix it, has returned with everything else for me to poke around with and see what can happen. And surprising to me, oh my gosh, there's another one in here. Okay. Let's see what we got here. Here's this one has. This must be the battery here. Of course, the idea is the Black and Decker battery is going to work on other things like a drill or something like that. There we are. Not at all what I was expecting, frankly. Well, I was hoping for another power supply in there. I got 2 radios. AM, FM radio, and battery charger. Looks like it's made for you to hook it up on your wall with a couple of large screws or fixtures sticking out of your wall. You can hang it up on there. Antenna. 2 radios, 1 broken power supply. Wow, that's pretty disappointing. You know, to have these 2 radios and not be able to operate them. Battery input. Black and Decker 18 volt power supply. Battery charger input. Battery charger input. 21.3 volts. Output. Output. Charge. 21.7 volts. Trickle. 21.7 volts. 210 milliamps. Trickle charge 80 milliamps. Risk of electric shock do not open. To reduce the risk of injury, the user must read and understand instruction manual. That should save their rear end in case somebody gets hurt. The device complies with some rules. Okay. Oh, here's some more stuff. Little charging light. Warning, 18 volts. To reduce the risk of injury, user must read the instructions. Caution, use only 18 volt Black and Decker NiCad nickel cadmium type power pack. Other types of batteries may burst, causing injury to persons. Damage or risk of a fire. Okay, well, we're not much further ahead. I was really hoping another old broken power supply was coming. Not the case. Now here's the whole deal here. It has this peculiar power plug, which matches this power plug. And the output here is, like it said, 21 volts, but there's another output on this. 11.4 volts. And there's two pairs of wires in the plug. You could just assume one pair is for one voltage and the other pair is for the other voltage. They've got 18 volts written here, but I guess that's more of a sales thing because people are looking for 18 volt systems, I believe. So the actual voltages are a little different than that. Well, what am I going to do here? I mean, almost certainly this is dead. Let's take a look at this battery. Okay, so recycle me 1-800-8 battery. Firestorm 18 volts. 18 volts. FSB 18 power pack. 21 volts and 11 volts. Where's the 18? Well, what I can try, I can determine for sure which of these terminals are positive and negative, is I can stick a power supply on here and start charging this battery. Right here, just using a shop supply. You can throw the battery in the radio and see if the radios work. Got two radios and one battery. Well, it's usually the other way around, isn't it? Let me get the voltmeter here. By the way, I don't think this will be a very long video. I'm not sure how long I'm going to want to do this, but what I'm hoping is I'm going to get absorbed in what I'm doing and forget about my my pain problems. We'll set this to 20. Nice big terminals, easy to clip to. What do we get? Yay. Oh, telephone time. Okay. That was good. So I've been getting phone calls from the Canadian Border Police telling me that if I don't call this number, I'm going to be thrown in jail shortly. The police are on their way. It's a typical scam call here in Canada. I was hoping they would talk on the phone, but... Well, okay, so there's a little bit of voltage there. Better than zero. I think this is really telling me which is positive and which is negative. So I have a negative sign here, so I'm going to reverse these leads. So, I don't really have much else to go on here. Could assume now I get a positive little voltage from here. Put the leads this way, so that would say that's positive, that's negative. Let's hook up a power supply and see what happens. Now I've got variable power supplies. I can limit the amount of current going towards the battery and that kind of stuff, so it's really quite safe for me to do this. And I gotta get a couple of fatso cords here. Yeah, the last few days where I have not been in the shop, that's I think the longest break I've had from shop work. Okay. These are good cords here. The longest break in years. Positive on this side. Okay, no short circuit there. Now the supply we'll use is a little overlit there. Use this one here. That's got a maximum output of all of half an amp. Did anything say what the charging current was? It did, didn't it? Something did say that. This guy at 21 volts will put out 340 milliamps, so we're within the range of the supply. Now, what's going to happen here? Okay, so this is indicating charging current here. A little hard to see the meter, but you can kind of see it jerking up quite dramatically as I turned up the voltage, but now it's gone way down. I think basically that's a bad sign, I would guess. So charging voltage 21 volts. Where are we on the voltage here? So we're only at 12 volts, so let's crank it up here to around 21. What do we got now for current? Hour. I can see the meter dropping off. Dropping way off. Around 100 milliamps now. Not very good. Not a good sign, I don't think. These are nickel cadmium batteries, did it say? NiCad? Hopefully I'm not wrong about this. Nickel cadmium batteries have a problem in which they build an internal short, a chemical short inside them, some kind of dendritic growth or something like that, or a pile of them right inside the battery. And once that short's in place, you'd have a hard time charging the battery up. Now if it's a single cell, that's one thing, but if it's multiple cells, this becomes a real problem. And probably there's 5 cells in here, or many more. It's got some screws, we can open it up and look inside. One or more of those cells probably has this condition. There is a way to restore them by firing in a heavy enough current that these chemical structures get melted off or disrupted and destroyed. But right now the condition could be there could be 4 good cells in here, and the 5th one has this shorting condition on it. That kind of ruins the whole deal. So I think we're going to need to look inside. It's dropped down to 50 milliamps now. Now is there a chance I hooked that up backwards? Well, yeah, I don't think that would be the case. Let's see what we got for voltage now. Might see a little increase in it. Whoa, there's a big increase. You can see it dropping, but I hardly spend any time charging it. Well, that's pretty interesting. That's kind of reassuring. The output voltage on this was going to be just says 18 volts. So I think what I'm going to do is I'm going to let it charge with that 50 milliamp current for a period of time, not long, just to get a little more into the battery. Then I can watch the meter action again here. By the way, thank you for all of you who wrote me emails in the last few days. I really appreciate it. But I don't require too much sympathy. You know, there's a lot of people in the world with a lot more challenges in life than me. I've just been dealing with a sore tooth, a toothache, nothing more. So the current, I didn't look, but I'm sure the current jumped right up and it just fell off. Double check the voltage here. 20, good enough. That small current isn't too much to worry about. So we'll let this just sit here for a while And then we're going to throw it in a radio and see if the radios come to life. And with a battery and a meter like this, you can get a reading off a battery. You can get a voltage reading off a battery and think, hey, look at that, there's voltage there. And there is, but this isn't drawing any current. As soon as you try to draw current, it could be the case that you're not going to get anywhere. But we'll find out. So it's 12 noon right now, so I'll let that just sit for a while. Okay, I think we're ready for some experimenting here. The impression I get is that there's trouble in this battery pack itself. I wonder if the battery pack is responsible for the overheating of the power supply. Don't know. Get 2 radios, only 1 battery pack. So I'm going to assume that there's a bit of charge in here. There's certainly enough to operate my voltmeter, but that's not much of a test. Now we got 2 radios to choose from to try. I don't think I can be selective here, so I'm just going to pick one. There's the on-off switch. Don't know how long this is going to last. We'll put it on AM because why not? Okay, here we go. See, actually, I'll turn this off, pop the battery in because it shouldn't draw anything from the battery until it's switched on. So this has some tracks here. This has some rails, but they're not the same arrangement. 2 radios look identical to me. What am I doing here? Okay, something stupid is happening. I don't see how that fits. Firestorm, it's gotta fit. Gotta fit. Can't be any more than that. This is supposed to. What am I doing? Doing something stupid here. This has got to go past some kind of a clip. Maybe I'm starting up too high. You know what? This is the track. This is the rail. Don't you want to go down? Okay. These are identical. Well, this works.
Our base pay raise.
Of course, in my shop, no radios work well in my shop. Didn't quite get it locked in. Okay, so we know this radio is working fine. No problem with it. This radio. Seems a lot louder. My imagination.
Guys who scored him were let into the grocery store, but I guess they don't have. They have screeners, but not really security.
I don't know if this guy was a security guard or if he was a screener, but at the end of the day, is it really worth people's jobs to really try to, obstruct someone from entering the store and...
Yeah. So, in Canada, most people are very compliant with the, COVID rules. Here, where I live, it's 100% compliance. I've never seen anything really out of the ordinary. Everywhere I go, I haven't been going anywhere lately, but people are wearing masks. Masks of varying qualities, but nevertheless wearing masks. And there isn't a lot of conflict about it. It's just, like, I think for most people, it's really not a big deal. Just put the mask on and go and carry on. I think that's the situation. Well, okay, what do we got now? We got 2 working radios, nothing wrong with them. We've got a battery which holds some amount of charge. Operates the radio for some short duration anyway. What we don't have is a way to charge this battery, and also what we don't have is the feeling that this is really working right. Let's get the voltmeter out again. And what did I do with my volt here? Here it is. Take a look at this. Voltage. Now it claims to be, look, it's going up. It claims to be an 18-volt battery. A radio like this is going to operate on quite a range of input voltages. So a heavily weakened battery could still make a radio like that work fairly well. Going up. They're all bad signs, I think, about the condition of the batteries in here. Okay, well that's something. I'm going to stop and think now a little bit. The owner of these 2 radios would probably want them to work from the battery so they become portable. You got 2 radios though, so you could perhaps station one somewhere, and all I'd have to do is connect an appropriate power supply, and I've got lots of... Don't you have a box of spare power supplies too? I have a box of spare supplies. I can find something that's going to work. So I can turn one of these radios into plug it in the wall with a piece of wire with one of these guys, plug it in the wall, and there you are. The radio operates. You just can't carry it around. Well, you could. You just pull the plug out and carry it around, but if the power goes out, that's not going to help you much. No charging, that's over with. That would be over with for that particular radio. The other radio, if there were a way to keep the battery charged, would be available if you wanted to use the battery. The question would be, how long can you operate this radio? Now, I mentioned there's probably a series of cells in here, and 1 or 2 of them has probably got an internal short in it. And that, in effect, is just like removing it, or putting a short around it. So instead of having, let's say, 6 cells operating, you only have 4 cells producing voltage. The other 2 are shorted. They end up with a low voltage like this. And some inconsistent behavior because of the 2 shorted cells. They aren't fully shorted. So occasionally you get a little higher voltage here maybe. If you charge it right up and then stick it on here right away, you might read a higher voltage, but the rock solid voltage is going to be something less. So I think it makes sense to take a peek in here now and see what they've really got in here. Okay, let's do that. Uh-oh, what kind of screws have they got here? Have they gone and used something? They've used some kind of you can't open it type screw. Looks almost like an Allen key would fit in there. I thought it was going to be a little easier than that. Let's see what I got. Do I have something that'll go in there? Maybe this will. Too big. Smaller one. Still too big. Smaller yet. So really, just maybe this. This is a different type of thing, but maybe it'll grip. Too small. Okay, I have sometimes a square will get into these kinds of things and get a grip. No. Okay, I've got something else for this. Let's see. Far too small. This is the exciting part of the video. Far too small. Not quite tight, but getting a bit of a grip. This is probably too big. Bingo. That's it. That's it. That's it. That's the one. Yeah. Okay, let's get these out. Yeah, doing this has made me realize how weak I've become. You know, you can lay on the couch watching TV and not really realize what's happening. But just taking these screws out has and why have I become so weak? Because I'm dealing with a dental issue and I haven't been able to eat properly for days now. And you know, I haven't got a lot of weight to spare. I'm pretty skinny, so not a lot of reserves. Oh wow, it just wore my wrist right out. Okay. That looks like it. Looks like it's coming apart right away on its own. It's jumping apart. Here we are. It's not 6 cells. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cells in this. 15 cells. Oh my gosh. Some of these are going to be in parallel, some are going to be in series. Boy oh boy. It's just got basic electric tape wrapped around the outside of them. Got this cover here, probably just trying to protect the contacts. I don't think it's physical. It looks like a little bit of chemical here. Looks like a lot of chemical on this one. So, one way to approach this problem is to try to reactivate the cell or cells that have suffered from this dendritic short circuit. And you know, I could have the story all wrong. I hope I don't. But in terms of, you know, is this the right kind of battery for this kind of issue? I believe it is. NiCad batteries. Remember battery life and never drain them all the way down. When you drain a NiCad all the way down, that allows this additional chemistry to start up. It begins to grow these growths inside. And once there's enough of them, you've got a short inside the battery. You can't charge it. You can't melt off this situation by putting charging current into it, because you can't put very much charging current in. The way to melt them off is to drive a heavy current through the cells that are in trouble. So you would literally hook up a power supply, not to charge them, but the other way around. As much as you may, whoa, yeah, definitely, it's definitely a whoa thing. You need good power supply, you're going to need 5 amps or something like that, only for a short while. And you jam this current through the battery, heats the battery up, melts these, or disrupts these formations. It never restores it to like new. And then you put the battery on charge right away. Presto, you're back in business for who knows how long. You keep the battery charged, never drain, never leave it laying around dead, and maybe you get somewhere. I've had some success with doing this, but it's not an issue these days because you're not normally dealing with nickel cadmium anymore. Now everything is L-ion and other types of batteries. Don't have this problem. You know, car batteries are similar in the sense that when you allow the charge to drain right out of the battery, new kinds of chemistry take place. And I think they call that sulfating. Sulfate. The battery sulfated. You get a build-up of sludge in the bottom of the battery, shorting, and all kinds of stuff goes on. That's another case of don't let them ever go flat. So the normal process, if there is one, would be to identify the particular cell or cells that have this problem, isolate them, and then treat each one and try to restore it back. Now, interestingly enough, there's enough juice in here to operate one of these radios for some length of time. Is this ready to fall completely apart? Yeah, it is. Layer upon layer. I wonder what this is. Okay, I don't want to take it apart. I don't plan to separate these cells. They're packed so tightly in here, if I separate them, you never get them back in this little tight container. You know, I'm going to put on my overhead light here. I'm working in the dark here unnecessarily. Just slide that back in. So another alternative to try to restore those batteries is to just take the whole battery pack and ram current through it. I'm really not inclined to even try it. A lot of trouble here. Sorry if that was a bit of a sharp sound on the video. Not inclined to try it. Be more inclined to see how long this battery, charged as it is, minimally charged, how long this guy can operate one of these radios as is. So I'm going to put it back in. I don't think I have to put it all the way back together. Let's see if I can just slip this on. Put it back in the radio. Switch on.
Run by the Soviets. No, Russia wants them back.
So I'm going to leave this radio playing now. The time is 10 to 1 in the afternoon. 10 minutes to 1. I'll leave it playing and I'll come in periodically and just see how much time we get out of it, because it could be surprisingly long. Great. Okay, I can't play that on my video, so I'll just leave it playing in here. Not too loud. We'll see what happens over an hour or two. Okay, let's see how that worked out. It's been 15 seconds. I didn't even make it out of my shop, and it's gone dead already. Well, that's the answer to that. You're going to get nothing out of this battery. Nothing out of it. And I'm sure if we put it on the charger and you know, the way I had it, put it on the power supply, charge it 50 milliamps, charge it for 24 hours, put it on here, this radio is going to play 1 minute. So I think the situation here is not only do we not have a functioning charger, we have a battery pack which is shot. So the last alternative is to find a power supply that can power the radio directly with a wire, you know, something like that, and just wire it right into the back of this radio and make it work. I think that's really just about all I can do. I could chop off this cord, use the cord, wire it up properly. Just use 2 of the 4 terminals, or right to it, have to figure that out. Find a power supply appropriate, that should be easy. Presto, you got a working radio. But the owner of this power supply said the person he bought it from is ready to refund him the money for it. So he'd like to get his money back on it. So if I cut this cord off, he's not getting his money back. I think that's decision time for the owner, what he wants to do. And I can potentially do that, well, I only have one of these, but I could avoid that and put a wire straight into here. No plug, no jack. Yeah, I think it's time for the owner to make a decision about what he'd like to do with his 2 Black and Decker radios. Okay, well, I'm going to bring this video to an end, and I have sent a note to the owner, and I've told him, throw it all away, move on, time to get a new radio. There are so many very inexpensive, very high performance, multi-featured little radios you can buy, you know, on Amazon or eBay or wherever. So many of them that are fantastic. This stuff has reached the end of the road. That's what I told them. So this is the end of the road for this video, and I'll see what happens next in here. Maybe another couple days before I'm back in here. Thanks a lot for watching.